Hi, hello everyone, welcome to today's session. Today we are going to discuss Ensemble machine learning model. In my previous video, I explained to you how to perform machine learning on banking dataset. So I took a dataset and I applied some machine learning algorithm and I explained to you how to do the basic classification technique in machine learning. So today we are going to take a different data set and we are going to apply ensemble models, and I'm going to show you how ensemble models are better than individual machine learning models. Okay, so before we get into the coding part, let us see what is ensemble model. Ensemble model is using more than one models or using the predictions of more than one models, okay, to get the final result. Okay, there are different types of ensemble models, like we have bagging, boosting, stacking and outing ensemble models. Okay, so bagging, so if you take bagging model, so here you can see different classifiers. Okay, each classifier is given a different set of data. Okay, it's trained with a different set of data and each classifier gives you the prediction. So here you can see each classifier is giving you the prediction and the predictions are combined. So either you will take the maximum vote or you will take the average of vote or you will take the minimum vote. So you can apply any technique to combine these oats. Okay, so this is one technique which is called as bagging. So the major important concept of bagging is you divide the data set into different subsets and each classifier will be trained with a different set of data. Okay, and the predictions of these classifier will be combined. Okay, using any aggregation method you can combine the predictions of this classifier. So this is bagging method. So in the case of boosting method, so for example here you take the full data and you train it with the classifier. The classifier will definitely have some error in their predictions. Okay, these error or incorrectly classified instances are given as an input to the next classifier so that you can adjust the weights, because some of the instances are wrongly classified, so you can adjust your weights. Okay, so similarly the output of the second classifier, only the incorrectly classified instances will be given as an input to the next classifier. So here you can see there is an opportunity for each classifier to learn from the mistake that it makes from the previous classifier, so that the final prediction will be better than the first classifier. So because every classifier learns there is an error in the prediction and then it adjusts its weights accordingly. So this is the example for boosting ensemble model. So here also you're going to use more than one ensemble, but each ensemble learns from the previous ensemble. Okay, and it adjusts its weights accordingly. So this is called as boosting ensemble. Okay, the next ensemble technique we are going to discuss is a stacking ensemble. So here you can see there will be two levels here. Okay, in the first level you can see some classifiers will be used. So this is level 1. So the entire data, the same data will be given to all the classifiers at level 1. Okay, each classifier will give its own predictions. Okay, and that predictions are given as an input to another classifier at the which is called as a meta learner. So you have two levels here. This is called as level 0 and this is called as level 1. So in level 0 you select some classifier, okay, and you give the same data and train those models. Okay, so here you can see there are 4 classifiers. All the 4 classifiers are trained with the same data. Okay, and each one gives its own predictions and the predictions are given as an input to another classifier at the meta, which is called as a meta learner. Okay, the output of this classifier will be your final prediction. So this is your stacking classifier. You have one more model which is called as voting classifier. So where you will have multiple classifiers and every classifier will give its own predictions, and how you combine the prediction based on that classifier is divided into hard voting or soft voting. So here you can see the last method which is called as voting classifier. You have two types, one is hard voting, other one is soft voting. Okay, so it is mainly based on how you combine the predictions. Okay, sometimes you take the maximum prediction of the classifier and you can take your final decision, or you can take the probability. Okay, so how you combine the predictions, based on that the voting is divided into hard voting and soft voting. Okay, so we will dive deep into the coding. So today I have taken the stock data set which is available in Kaggle for classification. So I will give the link of this data set in the description box. So you can just read the data set into the data frame. So this is reading the data set into the data frame. These are the features of the data set. So here you can see the patient ID, the gender, the age, hypertension. Then you have heart disease, yes or no, 1 and 0. Then married, yes and no. Work type, what type of work. Resident type, okay, glucose level, BMI, smoking status, and finally whether the patient has a stroke or not. So this is the target. Okay, this is our target. All the others are called as features. Okay, and this is the target that we want to predict. Okay, so the target is a binary class. It has only two values, either 0 or 1. 0 is a normal patient and 1 is a patient will have stroke. Okay, so it is a binary classification problem. Okay, so the first and foremost thing we have to do is we have to understand the data set. When we understand the data set, we have to find out how many null values are there in our data set. So here you can see DF. So this is the data frame where we have our data set. So we are checking how many columns are null value. Luckily, you can see only one column BMI is having null values. Okay, so we have to replace that null value actually. Okay, so we found out there is null value in the column, and also you can see some columns are categorical columns, like gender column you have male and female, married, yes and no, and the work type private, self-employed, okay, like that, business. Then resident type. So here you can see some columns are categorical columns. You know, all the machine learning models cannot understand categorical column. It has to be converted into numerical data. Okay, so we have to do some pre-processing technique before we apply the machine learning algorithm on this data set. So so to convert the categorical data into numerical data, we just use the basic method which is called as label encoder. Okay, so these are the columns which has categorical data. So I pass all these columns, okay, and create a label encoder. So here you can see you have to call apply label encoder dot fit underscore transform. So the entire data set will be transferred. Okay, so here you can see the entire data is transformed into numerical data. So here you can see only numerical data in all the columns. Okay, now we are going to replace the null value of the BMI column. So I'm going to take just the mean of the BMI column, okay, and fill all the null values with this BMI value, okay, mean underscore value. So here you can see I'm going to fill the null value of this column with the mean of that column. Okay, so now you can see the BMI column doesn't have any null values. Okay, now to how many columns we have? I think we have around some 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 11 columns we have. But this ID column will not help you to predict whether you have a stroke or not. Okay, so we can drop the ID column. ID column is not going to be useful for you. So we need all the other columns to predict the stroke. So you can also check which columns will help you to predict the stroke by creating the correlation map. So just call df.corr to calculate the correlation between the attributes. So here you can see some values. Okay, so it means the age. You can see how the age column is correlated with the other columns. Okay, so here you can see, okay, so here you can see how it is correlated with the stroke column, say age column. Okay, what is the correlation factor with stroke? Okay, hypertension, what is the correlation with the stroke? So if you have a positive value, it is positive correlation. If you have a negative value, it will be negatively correlated. Okay, so here you can see the ID column is 0, 0, 0, 0. It means it's not correlated with any of these attributes. So if any column is having correlation 0, you can neglect that column. Okay, that column is not going to contribute in determining anything. So either correlation can be negative correlation or it can be a positive correlation. So if any column is having correlation 0, you can drop that column. You don't need to use it for prediction. Okay. Now you can see this is to find the class distribution. So here you can see the number of rows which are normal, that is the Stoke value is 0 and Stoke value is 1. So you can see there is a huge difference between the two class. Okay, the Stoke class has very less samples and the normal class is having more samples. Okay, so the class is an imbalanced data set. So you cannot create a model on imbalanced data set. The model will not give you a good accuracy. So what we are going to do is we are going to use SMOT technique to increase the number of samples. Okay, so here you can see SMOT technique is used. Okay, just create an instance for SMOT, and then you can see the number of samples are improved. So just call fit_resample. Okay, and after resampling you can see the number of instances are improved. So you can see in class 0 you have 4861 samples and class 1 you have 4861 samples. So both the classes are equally distributed after using the SMOT technique. Okay, so here is a graph after the SMOT. Okay, now the class becomes a balanced data set. Okay, fine. Now the next thing that we have to do is our columns also have numerical data, right? And so we have to normalize that data. So that data has to be normalized. Okay, so we use min-max scalar to normalize the other columns. For example, we have age column, then we have glucose level, etc. So we have to normalize that one. So after we do normalization, now we have the data set with us, that is X resampled and Y resampled. Now we are going to divide that into testing and training data set. So here you can see the size of the testing is 20%. Okay, so we divide into training and testing. So once it is done, now it is ready, we are ready to create the models. Okay, so here you can see what are the models that I have created is, I have used a logistic regression model, linear SVC model, decision tree classifier model, random forest classifier, Gaussian NB, K nearest neighbor and extra tree classifier. So here you can see all these models are created, plus XGBoost classifier is also created. So here you can see. Okay, so just create these models. These models are available in sklearn package. So just you can create these models. So once these models are created, now you have to call fit on training data set. Okay, X train and Y train, and then you have to do the prediction on the testing data set. So you have to call predict on X valve. Okay, so and you get your predictions. Now you have to compare your predictions with your Y valve. Okay, that will give you the accuracy of your model. Okay, and then we have to finally print the classification report and the confusion matrix. So here is a code to print the classification report and the confusion matrix. So now since I have used this in a loop, okay, so all the models are executed and you can see the output for all the models, the classification report, the confusion matrix. Okay, the classification report and confusion matrix. Okay, so more than 7 models has been trained, so you can see all the result together. Okay, and then finally we print all the accuracies of the model. So this one I've already explained in my previous video. You can just go through the previous video to check the details of this. So you can see all the models, accuracy, precision, recall has been printed. Okay, and you can plot all these individual machine learning models. Okay, so the scope of this video is to explain to you the Ensemble model. So let me go to the Ensemble model. Okay, so let's start with the bagging model. Okay, So in the bagging model, the first thing you have to decide is the base model. Okay, which model you're going to use it as a base model. So here the base model which I'm going to use is the XG boost classifier. Okay, so we are going to use this as a base model, and then we have to tell how many estimators we need to create here. Okay, so these are the hyperparameters, so you have to repeat this for different values. Okay, so this is a base model I'm going to use. So in bagging model, the first thing that you have to select is the base model that you like to use. Okay, and then you have to select the value for n underscore estimator. Okay, how many estimations you want. Okay, how many times you want to or how many classifiers you want to create in the bagging model. Okay, so this is the code you have to use for the bagging classifier. Okay, and then here is the evaluate method. Okay, this method will print the accuracy, it will print the classification report and the confusion matrix. Okay, so I will share the code with you at the end of my video. So here you can see ADA boost classifier. This is another type of boosting classifier. Okay, here you have gradient boosting classifier. This is another type of boosting model. Then here is a voting classifier. So in voting classifier, you can see you have to create the base models. Okay, so the base models that I have selected are extra tree classifier, random forest classifier, XG boost classifier, decision tree classifier. So I have selected 4 base models. Okay, and then I have used voting classifier. So all the predictions of this classifier will be combined together. And what type of voting is used? Here you can see it's using soft voting. So in soft voting, every individual classifier will provide a probability value, okay, that a specific data point belongs to a particular target class. Okay, the predictions will be weighted by the classifier importance and will be summed up. Okay, so that is your voting classifier. So it will give you a probability value. Okay, based on how important this classifier is, you will give a weight for that classifier, and then the final predictions will be combined or summed up along with the weights. Okay, so in simple term, if I want to tell you, each classifier will give you a prediction, right? The prediction will be multiplied by the weight assigned for each classifier. Okay, and then you just add up. So that will be your final prediction for the soft voting. Okay, so you also have one more method which is called as hard voting. So here you can see hard voting. So here you see it takes the maximum vote. Okay, for example, the first classifier predicts as yes, or let's say 1. First classifier predicts as 1, second one also predicts as 1, third one also predicts as 1, and the fourth one predicts as 0. The maximum output is 1, right? So that will be taken as the final vote. So that will be your hard voting. Okay, so you have 2 types of voting classifier. One is hard, another one is the soft. So here you have to pass all your estimators. So here you can see we are using 4 classifiers, and finally we are combining the predictions of all these 4 classifiers using either hard voting or soft voting. Okay, so this is one method. The next one, we are going to use stacking classifier. In stacking classifier, I told you we will be using 2 levels, level 1 and level 2. So here you can see this is your level 1. So in level 1, what are the models we have selected? We are selecting XG boost, we are selecting extra tree classifier, we are selecting random forest classifier, and we are selecting decision tree classifier. So all these 4 models will be in level 1. Okay, in level 2, we are selecting linear SVC. Okay, is it hard coded to select linear SVC? You can use any classifier in your meta learner. Okay, this is called as meta learner. You can use any classifier in the layer, the second layer. Okay, so you can again try for different models and check what will be the accuracy of the model. So here you can see this is your stacking ensemble. Okay, so this is how we have to create stacking ensemble. So in stacking ensemble, you will have 2 levels, level 1 and level 2. Okay, in level 1 you will have many basic classifiers. In level 2 you will have a meta learner, so which will combine all the predicates. So that classifier will know how to better combine all these predictions. whether to use a hard voting or soft voting or how to combine these predictions, it will be automatically selected by the meta learner. Okay, so this is your stacking ensemble model. So here you can see the accuracy of all the ensemble models. So in this you can see, for this data set you can see the stacking ensemble model gives you the highest accuracy of 96. Okay, so here you can see highest accuracy is 96. So let's compare the accuracy of individual models. Okay, so if you take individual models, here you see the highest accuracy is 95, extra t is 94. So in stacking ensemble we got it as 96. Okay, the highest accuracy is 96, and this is the combined graph for all the accuracy, precision and recall. So you can see the accuracy of bagging, boosting, soft voting, hard voting and stacked ensemble. You can see the stacked ensemble model is the highest when compared to all the other ensemble models. So hope you understood what is ensembling technique. Ensembling technique is combining the predictions of more than one classifier. Okay, and there are different ways to combine the predictions. That's what we discussed in bagging, boosting, voting classifier, and finally in the stacking ensemble model. Hope you like this video. Thank you for listening. Bye bye.